Welcome to Study Loop.
Okay, so for this one, we're going to be using the differential star count formula for an infinite universe. And we're going to show that the amount of light arriving at Earth from a cone with a solid angle, omega, diverges exponentially as the length of the cone increases without bound. And we're going to assume that all stars in the field have the same absolute magnitude. Okay, let's start out with the flux received from a star. So the flux received from a star, F, equals F at 10 parsecs times 100 times negative apparent magnitude, little m, minus absolute magnitude, big M, divided by 5. Now, we also know that the number of stars with absolute magnitudes between m and m plus dm found within some solid angle omega, having some apparent magnitudes, little m and little m plus dm. Remember, these are apparent, these are absolute. We have the formula d in capital M equals a m times d little m. This is just a formula from the book. That means that the total flux due to all stars with apparent magnitudes between little m and little m plus d little m must be df little m equals f10 f10 times 100 times, or 102, the little m minus big M over 5 am capital M times d little m. Okay, and we know that there's an expression for this guy right here. So all that you have to do is literally write that down from the book. Okay? So, and if we let little m go to negative infinity, then at some distance d that corresponds to an apparent magnitude of little m, we get fm equals integral negative infinity to little m f10 times 10 to the negative 2 little m minus big M divided by 5 times ln of 10 over 5 omega in big M 10 to the power 3 little m minus big M minus 5 over 5 d little m. And c is a constant. Now all that you have to do is plug that into your integral solver, or take it step by step and multiply it all together. But after you're done integrating, you should find that f of little m equals 5 times, now watch this, I'm going to do a constant. So I'm just going to say capital C. So C is a constant. 5 times C over ln of 10 times 10 to the m over 5. And that means that as d goes to infinity, m goes to infinity, and fm goes to infinity. If you wanted to simplify this in my integral solver at least, I got a simplification equal to my constant c times the integral negative infinity to little m 10 to the m over 5 dm, and that's pretty easy. Okay.